Hello. Thank you for coming. Good afternoon. My name is Greg Silin. I work at Nitro on the platform team. And we're building the next generation of the smart document collaboration APIs. So the title of my talk today is Streams of Scala Collections. We'll start by presenting the problem of iterating large S3 buckets, large production S3 buckets at scale. We'll talk about how we solved it using play Iteratees streams, and then we'll just arrive at the abstraction with the familiar Scala collection APIs. And we've also open sourced our work, so if you're interested, we're always looking for contributors, and more on that later. All right, let's start. So I'll kind of skip over the agenda because I just said it. So just a little bit about Nitro, who we are and what we do. And these two slides really speak to me because I didn't initially find working with documents sexy, but when you kind of look at the way that you're used to doing any kind of contracts, offers, or health insurance documents, you're probably printing them, you're signing them with paper, or filling out forms, and then you're scanning them back into the computer, and then you send them over, and then you forgot to sign something, so they'll send it back to you, and then you just have like multiple copies, and maybe one of them is correct. So it's it's a little tedious, and then there's no source of truth for what you're filled out, what your document is. So enter the new way. Now you can create your document, upload it online. You can basically go through all the flows, and everybody sees the same version of your document. And so it was pretty epic for me personally. Like, I do all my stuff, all my forms and signatures through Nitro Cloud, and it's great for businesses. So our Smart Documents for Everyone. Nitro accelerates the way businesses create, prepare, and sign documents anytime and anywhere. So it's pretty powerful, I think. So a little bit about reactive systems at Nitro. The four pillars of the Reactive Manifesto. So we got to be responsive. Some of these documents could be megabytes in size, and we have to process, render, and understand the document in a pretty fast and responsive manner. Our document workflow system is message-driven, we have a worldwide user base, and so we have to be able to withstand the demands of our users across the globe. And with tax season coming up, we'll have a spike, and so we have to be ready for those challenges. And finally, resilient. Something I touched upon in the elastic portion. We have to withstand failure. So, because a lot of our business users are relying on our system for the critical business needs, or my personal critical needs. So I want to dive in a little bit on smart documents at scale. So just to kind of give you an idea of the complexity of the system. So as you might have guessed from the title, we use S3 for storage, Amazon S3. Each document could have multiple pages and formats, each of which become multiple S3 objects. So the flows that I was talking about, each of these flows will potentially produce a new version of the document. So now you got multiples of your pages and formats for a single document. And so with multiple documents per second, versions per document, pages per version, we have basically billions of objects in S3. And it looks like I derped in the slides, but basically, we have millions of document uploads a day, and so that's just basically the math that was supposed to be up front. So sorry about that. So kind of like why streaming collections? Why streams at all, right? So the things that are fairly, easy on a single computer, or maybe like even a large database, like counting, copying, extracting, cleanup, they kind of become really non-trivial with Scala. So, even a 1% error margin with a billion of documents, it's 10 million that you have to account for. And that's money for the business. And that was actually one of the motivations for this project. We had a production bug that was not cleaning up files in S3. And so we had to go through the whole object collection and find the ones that were orphaned and left out. And it's not a huge amount of money, but it's always good to save. So how do we traverse this data? So at least at the time we were starting this project, command lines weren't providing the flexibility and the scale that we were looking for. Pretty obvious, you can't load everything in memory or on the RAM or on the disk for that matter. I think the data is over a few terabytes, so that you couldn't even load it on disk. So we clearly needed some batch solution. So, and the Amazon S3 SDK, just for those of you who are not immediately familiar with it, it has a Java iterator. So you can do a iterator of all the objects, or it has a more sophisticated API for doing a prefix-based iteration, which, as a side comment, kind of allows you to be a little more clever about, restarting failed iteration or splitting up your work in pieces. So, but for the slides, just to make it simple, I'll keep the original basic one. So when you iterate the bucket, you get something very simple. It's just essentially metadata about your file. The bucket name, the key, the size when it was last touched, and for most of the examples, we'll just care about a couple of those. And so that's how the Java code looks, and I won't go over it. And by the way, can you guys raise a hand if you cannot see this whatsoever? Yeah, not so good. Okay, lessons learned. But the idea was just to show that it's pretty gnarly. And so we're Scala engineers, so we're going to talk about a streaming solution. And since we're reactive, as we said, we're going to talk about asynchronous streams. So, and just as a side note, you can't. I talked about splitting up the work, but you can't really over-parallelize your iteration because Amazon will throttle, so you have to be kind of careful at doing it fast, but not too fast. And so now that we've said that we're going to use streams, so what kind of streams? So we actually use the play Iteratees. And just for those of you who are not immediately familiar with them, you have the enumerator, which is the source, and then enumeratee, which is the transformer, and then the iteratee, which is your consumer or the sink for the stream of data they're consuming. So why this particular library? So at the time it was the most mature technology, in asynchronous streaming in Scala. And we had production experience, so that was the technology we picked. And I'm just going to show Iteratees at work via a counting example of just counting all the objects in a bucket, pretty basic. So we're going to start with forming our asynchronous enumerator source. And you guys cannot read that at all, probably. Let me see if I can do anything. No. Okay, well, my apologies, but I'll just try to walk you through it regardless. So the top line would have been just using the underlying Amazon Java API to produce the iterator, and then basically using the Scala implicits to convert to the Scala iterator, and then feeding that into the enumerator API to produce an asynchronous stream source. Now, it's not exactly fully asynchronous because the underlying Java iterator is not fully synchronous. It does load objects in batches as you request them, but it's not truly asynchronous. It doesn't work with features. So, but the idea is to abstract it into an asynchronous stream now and then improve later. So we get an enumerator of Amazon objects. So stream them all. So this one is a little more involved. So this is our transformer. So in this example, we're just going to batch it into a list of arbitrary size, and so I'm not sure how much you can see here, but basically what happens is this transformer takes a internal consumer that basically takes the stream and forms it into lists or whatever collection you're using until the size is reached, and then it stops consuming, and then you move on to the you produce the new batched element into the new stream and then start again. So that's kind of the idea. And finally, now that we've formed that stream, we've batched it, and now we're going to count all the elements as we're basically the reducer and the map reducer, the consumer, the iteratee in this nomenclature. So for every batch, we just simply add up the size, and so now we're going to tie these things together. So take the enumerator stream, pipe it through the transformer, and then into the reducer, and that produces a future of integer when it's all done, and you can find out your total size. So can this really be simplified? It's not really rocket science, but it can be a little tedious putting all the, figuring out the abstractions and putting them all together. So can it be simplified? So we're all familiar with Scala collections. And all the familiar methods like map, filter, for each, grouped, and count. And you can compose them, and so it's a lot more easier to reason about development with the Scala collections than it is with the streams. So now again, apologies if you cannot see it, but now we basically have an iterator that has the asynchronous streams underneath, but it just exposes a very simple Scala API. So we have the head option, find, map, for each, filter, group, count, fold left. So all the familiar collection APIs that you can call without understanding how the streaming stuff works underneath. So now just that's what grouped and count look like. It's just the same implementation, but under the covers. And now my code becomes just a simple one-line implementation. So obviously I need a helper to produce the stream first of all, but once I do, it's just one line to batch it, count it, whatever I want to do with it. Here's another example. So the bug that I talked about, cleaning up files that you no longer map to in your database. So we take our stream, we get the keys, and we filter it on, filter it based on the keys that we do not recognize, and then delete the object out of S3. So just in 3 simple lines. And another example, I might want to reprocess or extract data from let's say yesterday. So again, just the summaries have the date on them, so I can just filter the stream based on some time range, and then feed it into my next either my indexer or whatnot. Okay. So we don't have to stop at S3. You can extend this model onto any other data source. Really, you can relational DB, Elasticsearch, the big tables, and even Spark. And the idea is, so in some of these tables, or some of these databases do provide ways to actually scan the data. So not all of the use cases will be applicable, but if you need to extract and process, basically a large piece of data, you can definitely do it with this library. And so at Nitro, we usually end a presentation with a quote. So in this case, I think this kind of highlights the abstraction pretty well. We don't want to write code if we don't have to. So laziness moves our progress. So what did we learn today? Scaling is not easy. A lot of us face that challenge every day. But Iteratees or asynchronous streams are good for traversing large amount of data. And while it can get a little tricky or just wordy coding the streams, the stream collection abstraction actually makes it a lot more simpler. So where are we going to take this implementation? We'll continue working on a reactive client. We do use this in production, and we'll introduce other implementations such as Akka streams or and compare and contrast and see how they perform. Now onto the open sourcing. We have open sourced this work, like I mentioned earlier. Just want to call out Mark, who is the other key contributor on this repo. Most of the good ideas come from him. And if you're interested, please contribute. And let's, if you're working with this 3 or just any other streaming technologies, we welcome collaborators. Talk to me after the talk if you would like to discuss this further. So just a quick note on the Scala Days conference. We're a gold sponsor. Meet us at the community booth just outside of the Herbst Theater. We are sponsoring a couple of events. The Unconference tomorrow sounds interesting. You can propose and give a talk on the same day. There will be 3 tracks downtown galvanized. So definitely talk to us if you're interested in that. There's a meetup tonight at Stock and Trade, a Spark meetup tomorrow, and a Shapeless training at Nitro, which I'm not sure if it filled up yet, but definitely do apply. And a final note, we're hiring. And I'll open up to questions. I guess pretty short presentation. Yeah.
You started working after stream on new implementation. Did you make any effort to control back pressure? Something like this?
Yeah, it's a good question. So so the question was about back pressure. So kind of the initial prototype implementation just used the built-in Amazon library. It has a backup. What is it called? There's a helper they provide. So we used that initially, and just pause really between collection. But so we're looking to build that out as well.
Another question.
Mm-hmm.
So your producer Async and so on basically replicate the master stream file. What is the additional value in your approach in comparison with master stream?
Are you talking about the Iteratees or the? So the Iteratees is not our work. It's
All your framework. What is the additional value streams directly to Amazon API?
No, sure. It's just using a different library. So, but the addition was just the composable Scala collection that you can use on top of the stream, so you don't have to actually put your stream together and do all the piping and stuff. The question was, what was the addition between the libraries? Yeah.
The last one.
Mm-hmm.
Since you are working with AWS, have you considered any Scala wrappers for AWS SDK? And if you see, what is your opinion?
Well, yeah, sure. The question was, have we considered any Scala wrappers for AWS? So we looked specifically at S3 because that's where most of our work is, so that's part of the work is we're building our own. There's always value, right? Because you have so much more power to make libraries that are composable and extendable in Scala than in Java. Any other questions? Thank you, guys.